Today, everybody throws around these terms you hear every time you turn on CNBC, the news. My friends talk about it all the time. CPU, GPU, TPU, and quantum computing. Many people ask me, what the heck do all these terms mean? So I'm going to break down each one of these and put them in simple terms of what they actually do and where they live inside of different computers. So the first one we're going to start with is GPU. This is one that's been around forever. Is the graphic processor unit. So it is the one that's the hottest, NVIDIA. So when you hear GPU, a lot of times people are using it interchangeably with NVIDIA. Not quite the case. There is also other GPUs. GPU is for parallel computing. So it is for when you need to do things very fast, very math-based, and is what is used for a lot of the computation. So when you hear about AI and why they are doing what they are doing, it also came out and became very popular during crypto, which is still a thing. People do crypto. And crypto mining is very much based off of parallel processing. You want to do a lot of things at once. So that's where you need this GPU. Gamers love it because it gives them that high refresh rate and polygons in online games and high resolution games. So it allows their computer to give them ultra realistic frame rates very fast and give a leg up on the competition. You might be able to see something that your gaming competitor doesn't. Same thing in when you're talking about business and doing high-speed computations. That's going to be where the GPU comes into place. CPU is where all of this started. So CPU is what most of us think of is Intel, AMD, Apple M3, M4, M5, processors. Another one out there is Snapdragon and what's inside of phones and mobile devices. Very good. So these are your general processing units. So that's what it really means. It's your central processing unit is what it stands for. You can get a lot of cores and you do get a little bit of diminishing return when you're putting it all in the same chip. Intel is working on how to make things a little bit more efficiently with that, and their dies and the latest gens are of course faster than the previous. But CPU is really very much your general. So this is what gets used when you're doing a Zoom call, when you're doing Excel, when you're doing Word, when you're doing a million things and running applications. That is your CPU. So when you're playing a game or doing AI type things, it's a combination between the CPU sending the instructions up to the GPU is where that comes into play. So you kind of need both. But think about this. Your CPU is a brilliant chef that can do a lot of things. It may have a Michelin star, but can only do one or two dishes at a time. The GPU is where it's going to be able to do 1,000 dishes at a time. So it's a mass production. Also now let's throw into it TPU, Tensor Processing Unit. TPU is specialized. So Google builds a lot on these. So you've used these actually when you've done your Google searches for years. It's not something new. They've had out for a while. They're lower cost, where you're going to think about the fact that it is a very specialized. So if we're using the cooking analogy, CPU is the chef, the GPU is the line cook that is slamming out the dishes very quickly. The TPUs are the robots that are washing the dishes in the back and able to go through at very fast speeds and make that back of house very efficient. But they're not able to do things necessarily in super parallelism like a GPU, but they are at superhuman speed. They're very tailored into that tensor processing to be able to make those inferences very quickly. When you type something, you mistype it, you might mean something else, you have different dialect. It's able to bring those together. It brings the power of a Google search, translate, training, and that's how Gemini really works. So that's a very common thing is, when you're using Google products, you're using TPUs. Other people use them as well. I will show in another video our Lenovo big desktop computer that we have, a workstation that we use for local AI that actually has 2 GPUs and a MPU on board with it to be able to do our testing. But it's got an Intel MPU. It doesn't actually have a Google-based one. But the final piece I'm going to mention, quantum computing. So this is something very futuristic. It is coming to fruition. AI is going to help bring quantum computing more mainstream. So quantum computer, think about if you were to take a whole data center worth of compute power and put it into one chip. And these chips are not cheap. They're millions of dollars. The apparatus to run them are millions of dollars, but it's a data center worth of compute power into a chip. Why do you need this? The compute power that we use today is really based off of ones and zeros. Quantum computing is a little bit different. It's based off of the fact that it's not just on or off, it's on and off at the same state. And that brings a whole nother level of computation to the realm. A little hard to explain, but these qubits is how you refer to it. Think about the type of computing that you need to do if you're going to engineer new molecules to make a new type of asphalt or plastic to revolutionize manufacturing. And you need to feed into your AI to create at a nano level. So now you're not just dealing with like mixing of different ingredients. You're going down and mixing ingredients at a molecular level. That is really where quantum computing. So cryptography, drug discovery, optimization for big world problems like energy. That is where quantum computing comes. And that's kind of the realm that AI is going to help drive as things come faster. But quantum computing is one of those things that's not brand new. It's something we have seen coming on the horizon. It's speeding up our trajectory to using quantum computing. So if you have any more questions about these, hit us up in the comments and give us your comment on what you think of these different types of processors.